Welcome to the presentation on microservices design in detail. In this session, we will explore the core concepts of microservices architecture, including service decomposition, API gateway, and inter-service communication. Let's dive in. Microservices architecture is a design pattern where applications are broken down into smaller, self-contained services. These services are designed to handle specific business functionalities and can be developed, deployed, and scaled independently. The key benefits of adopting microservices include scalability, independent deployments, and better fault isolation. Service decomposition involves breaking down a monolithic application into smaller services. To do this, we typically rely on domain-driven design, where we focus on the business domain to identify natural service boundaries. The challenge lies in determining the right granularity of each service, ensuring that each service is sufficiently independent yet cohesive in its functionality. To identify services, we use various techniques such as user stories, process mapping, and event storming. These methods help us analyze business processes and identify logical service boundaries. However, a major challenge is deciding the right level of granularity. Too small a service can create overhead, while too large a service might defeat the purpose of microservices. The API gateway acts as a single entry point for all client requests. It is responsible for routing requests to the appropriate microservice, managing authentication and authorization, and aggregating data from different services if necessary. Popular tools like Kong, AWS API Gateway, and Nginx can be used to manage and orchestrate API calls efficiently. Microservices rely on communication between services to function effectively. Synchronous communication can be achieved using REST APIs or gRPC, while asynchronous communication often uses message queues like RabbitMQ or Kafka. Event-driven systems enable services to react to events, making the architecture more responsive and scalable. In microservices, each service typically has its own database, ensuring that it is autonomous and scalable. We encounter different consistency models such as eventual consistency, which is often favored in distributed systems, and strong consistency when transactions require guarantees. Patterns like Saga help manage distributed transactions in microservices. Fault tolerance is crucial in a microservices architecture. The circuit breaker pattern, for example, helps prevent cascading failures by stopping requests to a failing service. Techniques like retries with exponential backoff can also help recover from transient failures, ensuring that the system remains resilient even in the face of errors. Security is a fundamental consideration in microservices. Each service must be securely authenticated and authorized using methods like OAuth2, JWT. Service-to-service communication can be secured using mutual TLS, while data encryption ensures that sensitive data is protected both in transit and at rest. CI/CD pipelines are essential for automating the deployment of microservices. Tools like Kubernetes and ECS allow for seamless scaling, ensuring that services can grow independently based on load. Techniques like blue-green deployments allow for safer updates, enabling rollbacks if necessary. To build and manage microservices, we use a variety of frameworks and tools. Spring Boot is a popular choice for Java-based microservices, while Micronaut is a lightweight alternative. Docker and Kubernetes provide the containerization and orchestration needed for scalable deployments, and monitoring tools like Prometheus and Grafana help ensure that the system runs smoothly. Let's look at a real-world example of microservices in action: an e-commerce platform. Here we could have a order service, inventory service, shipping service, and user service. Each service handles a distinct aspect of the platform, and they communicate with each other to provide a seamless customer experience. While microservices provide many benefits, they come with challenges. Service discovery is essential for locating services dynamically, and tools like Netflix, Eureka, or Consul are commonly used for this. Monitoring and logging become more complex, but tools like the ELK stack and Prometheus offer solutions. Additionally, ensuring data consistency and managing distributed transactions are crucial considerations that must be carefully designed. To summarize, microservices architecture enhances scalability, flexibility, and fault tolerance. Service decomposition is critical to success, and careful attention to API gateway management, inter-service communication, and data consistency will ensure a smooth operation. Security, resilience, and the right tools and frameworks play a vital role in the robustness of your microservices-based system. Thank you for your attention. If I would now like to open the floor for any questions or further discussions. Please feel free to ask anything related to the concepts we have covered today.